Hi friends, welcome back to chemistry classes. Today I am going to start language of chemistry. Now what is language of chemistry? As you know, there are different languages and like maths, chemistry or like English, Kannada, Hindi. But language of chemistry means a chemistry has its own language such as symbol, equation, ion, valency, atom, element and molecule, reaction, so on. This English means it has separately grammar or literature, and Kannada again it has grammar and literature, or Hindi again grammar and literature. Like that, every subject has subtopics in it. Here, language of chemistry means how chemistry has its own symbol, own language such as symbol, equation, ion, atom, valency. Like that, it is preferred chemistry. Now, let's learn about symbol. Symbol is a short and representation of an element. It means when there is an element, there will be a certain symbol to that element. Here, oxygen. Oxygen has certain symbol that O. Here next, if we take hydrogen, it has H. And if we take fluorine, F. Neon, Ne we will get. And different more atoms like sodium, Na. These symbols are derived. Some are derived from Greek, some are derived from some are derived from the names, and some are derived from the planets or elements. Here there is an element named as Neptunium. It is derived from the planet Neptune, or uranium from Uranus planet. And next Mercury. Next, this sodium means Na. Na in Greek it's known as natrium. So they kept its symbol as Na, and English name is sodium, like that. Now chemical formula. Chemical formula is shorthand representation of an compound. If here there is a H2O. H2O means water. Every time we can't write H2O in the chemistry. Every time we can't write water in the chemistry. So we just prefer it as it is oxygen hydroxide. So this its formula O and H. So it's known as H2O. And here CH3COOH is acetic acid or vinegar. So we'll write as CH3COOH according to its formula. Next, ion. Ion is an atom or group of atoms where electrons differs with the number of protons. It means ion is an element where electrons and protons are not of same. They are differing. Here cation. Cation has more protons than electrons. It means cations is a positive ion. There are two parts in ion, that's anion and cation. And when it comes to cation, cation is a positive ion. Cation has more protons than electrons. Why? Because proton has positive charge and electron has negative charge. If there are more positive charge, then it will be obviously cation. If more negative charge, then it's anion. Cation examples are Na plus, Ca plus 2, H plus. Na plus means sodium, Ca plus 2 calcium, H plus hydrogen. Here, if we take anion, O minus 2 oxygen, F minus fluorine, Cl minus chlorine, like that. Now, let's learn about chemical equation. Chemical equations are the symbolic representation of chemical reaction. In labs, we will be doing more and more chemical reactions in which reactants and products are expressed. First, we use some reactants, and after some reaction, we get some other products. Here, but the original products will be at the final product, but they'll be differs in some ways. According to the respective chemical formula, they'll be expressed. Here, carbon and oxygen, if we mix this carbon and oxygen, we get carbon dioxide. And if we take H and H2 plus O, then we get H2O. Like this, after certain chemical reactions, we get new chemical equations. These are called C and O2. Here, these are reactants and these are products. And there are four types of chemical equations. They are direct combination, also called a synthesis reaction, decomposition reaction, displacement reaction, and double displacement reaction. Now let's learn about balancing equation. When there are reactants and products are equal in chemical equation, then it is called as balanced chemical equation. Here, reactants and products should be equal. Then the chemical equation is balanced. It is rule that every chemical equation should be balanced to obey the law of conservation of matter or law of conservation of mass. Here we just mixed the H2 and O2, because H2 is a molecule and O2 is a molecule, we get H2O. But here before these two there were only two hydrogen atoms, and here two hydrogen atoms, it was perfect. And when comes to oxygen, there were two and there were only one. So we written here 2 and we got 2 oxygen but 4 hydrogen, and we placed it here 2. So we got at reactant side 4 hydrogens, 2 oxygen. At product side 4 hydrogen, 2 oxygen. Wherever we can't keep the numbers, like we can't place the number in the middle of this compound. We should place the number exactly before the compound or molecule. Here we can place here any number, or here any number we can place, or here we can place the number. Next, this balanced chemical equation should be in the simplest ratio. Here 2, 2, 2. Here we can write as well as 4, here 2 and here 4. But it should be in the simplest ratio. Next, here Mg plus O2 gives rise to MgO. Here it is just an example to solve. Here there is 1 Mg and here 1 Mg. Here 2 oxygen but here only 1 oxygen. So if we write here 2, we get 2 oxygen but 2 Mg. So if we write here 2 itself, 2 Mg, 2 Mg, O2, 2O. It's balanced. So 2 Mg plus O2 gives rise to 2 MgO, that's magnesium oxide. Next, as we know that there are 4 types in chemical reactions. The first one is direct combination reaction, also known as synthesis. It means when two reactants chemically form new substance which is a compound, is direct combination reaction. It means two molecules mix together and form new compound. Here N2 plus H2 gives rise to NH3. Here this is not balanced. This equation is not balanced because here there are nitrogen 2 atoms and here 1 atom. Hydrogen 2 atoms, hydrogen 3 atoms. So if we write here 2, then nitrogen will be balanced, but hydrogen is not balanced. Here hydrogens are 6. Here we should multiply this every time when there are like this 2 into 3. Then hydrogen atoms are 6. Here there are only 2. If we write here 3, then 3H2 and 2NH3. Here N2, here N2, 3H2 and 3H2 or 2H3. Both are same. Here 6 hydrogen atoms, here 6 hydrogen atoms, here 2 nitrogen, here 2 nitrogen. Next, these are the examples of direct combination reaction. It means two reactants combine and form one reaction, one product, that is direct combination reaction or synthesis. Here CaO, that's calcium monoxide plus water, we get calcium hydroxide. Here if it is like this, like Ca and here taken twice, it is OH is taken twice, CaOH taken twice. Next, here H2 plus S gives rise to H2S. These are the direct combination reaction. It is very simple to remember that direct combination reaction. It means A plus B which gives rise to C is direct combination reaction. Simple. Next, decomposition reaction. It is just reverse to direct combination reaction. Here in direct combination reaction, two reactants form one product, and here in decomposition reaction, one compound form two products. That is just simple. Here H2 and O2 gives rise to H2O plus O2. This equation is not balanced because here there is H1 and here O2. H2 and H2 are balanced, but here oxygen is 2 and here oxygen is 3 because here O2 and O. Here if we write 2, we get 4 hydrogen and 4 oxygen. But if we write here 2, 2H2 plus O2 gives us to 2H2O plus O2. Here 4 hydrogen, here 4 hydrogen, here 4 oxygen, here 2 oxygen plus 2 oxygen, 4 oxygen atoms. That's it, simple. Here decomposition means one product forms to two different products. ZnCO3 gives rise to ZnOCO2 and here H2CO3 gives rise to H2O plus CO2. If these two are balanced, then post in the comment that if balanced, and if didn't balanced, please balance them and send me. I'll be giving the answer. Here this simple trick to remember this is C gives rise to A plus B. That's it. It is decomposition reaction. Next, it is displacement reaction. Before going to displacement reaction, let's learn about metal reactivity series. This reactivity series of metal is also known as activity series. Refers to arrangement of electron in descending order of their reactivities. Metal reactivity series means how metal reacts with any other metals. Here potassium is highest and most reactive with any other metal, and next it comes sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen and carbon. These two are non-metals but also they are in metal reactivity series to just for our reference. And next, after hydrogen, copper, silver, gold, platinum. Next, it is most mandatory to remember these metal reactivity series. Next, now displacement reaction. Displacement reaction is one where one atom is displaced by another atom in a molecule according to metal reactivity series. Here there is CuSO4. If I explain this example, you will easily get to know this. If CuSO4 plus Fe, here you know that Fe is highly reactive than Cu because according to this table, copper is here and iron is here. So iron is more reactive than copper. So it replaces copper and it forms with bond with SO4, that is FeSO4 plus Cu. And here NaNO3 plus K, which gives rise to KNO3 plus Na. Here K replaces Na and forms KNO3 and leaves Na. And here AgNO3 plus Cu gives rise to CuNO3 plus Ag. They just replace this like A, which is A it is like A plus BC, which gives rise to AC plus B. It is a trick to remember the displacement reaction. Next, double displacement reaction. A double displacement reaction in which positive and negative ions of two ionic bond exchange their places to form new compounds. Here it means there will be two compounds and here these will interchange their places. That's it. It is just double displacement reaction. It is easy to find double displacement reaction than all reactions. Here A plus B, AB plus CD, which gives rise to AC, AD plus BC. That's it. Here A and C are positively charged cations where B and D are negatively charged anions. This double displacement reaction mostly forms between ionic bond. Here AgNO3, Ag plus NO3 minus and NaCl, Na plus and Cl minus. So here these both are replaced, that AgCl plus NaNO3, and here NaOH plus NH4Cl, which gives rise to NaCl plus NH4OH replacement, and here HCl plus NaOH and H2O plus NaCl. Next, there is a small topic of related to this reactions or any other reaction is neutralization reaction. It means when acid and base react to form salt and water, then it is known as neutralization reaction. You can note it down that neutralization reaction is a reaction where acid and base react to form salt and water. Here we can find base by identifying OH in that and acid by H. Here NaOH is a base and NH4Cl is acid. Here these two get reverse or these two interchange their places where NaCl and NH4OH is water and NaCl is salt. Or this is a better example that HCl, you know that common HCl is an acid and NaOH is base. HCl, this is a strong acid and this is a strong base in chemistry. Here HCl and NaOH. Here H2O. Here when these interchange their places, it forms NaCl plus NaCl plus H plus OH, which gives rise to NaCl plus, here H and H both are belong to same group, so H2O plus NaCl. That's it for this class. Thank you. I think you have find it interesting matter or interesting topics in this video. So if you like this video, please like and forward to your friends, and they may also get help by these chemical reactions. Thank you. Subscribe to our channel. That's Steady to IIT. Have a great day.